Hey guys, so today we're going to be making a depth system, and I have made videos on depth systems before. It was actually one of the first couple videos I ever made, and I have it in my farming series, but it's been a couple years and I kind of wanted to update the system and condense it into one video, as well as incorporate some of the frequently asked questions that I get about it, which will kind of add a bit of functionality to the existing system. So just to begin with, I want to explain what a depth system even is, what I actually mean by that. So a depth system is going to be something that is controlling the depth at which our instances are drawing at. So in your projects, if you don't have a depth system set up, you're going to be getting this kind of behavior. So even though we might expect an object higher than another one to go behind it, this isn't actually a built-in functionality. In GameMaker, we have to set this up ourselves. And there's a lot of different ways that you can do this. My way is going to be specific. It's not necessarily the best way or the most performant way. It's just a way that I find relatively easy to set up and explain. And it allows you to kind of keep the layers which have their own depths, you might have realized. So for example, just in my room right here, you can see I have ground, which is in these tiles, right? That's the ground, which is below all of the instances. And if you look right here, that's because the ground is at a higher depth than the instances layer, right? So anything with a higher depth, just think if it's higher, then it's kind of deeper, it's further away. So things with a higher depth are further away. And instances themselves can have a depth. So I could set the player, for example, if the player had a depth that is lower than the tiles, then it's going to appear in front of it, which is kind of what happens when you place it into the instances layer, for example. So every instance in the instances layer gets set to a depth of 0. And from then on, what determines the order in which they draw, so if a bunch of things have the same depth, then what determines what gets drawn on top of the other thing is actually just who runs their draw event first. And you can kind of picture that as if we have a blank canvas and we go ahead and stick a bunch of stickers onto the canvas, the sticker that you put on first is going to end up behind everything else. And we are going to take advantage of the draw order in this system that I'm going to be talking about today. So we're going to have all the instances up the top, drawing first, and then as we go kind of down the room, the instances will be drawing one after the other. And the variable that we are going to be looking at to control this is, of course, the y variable. And as you might know, the y-axis starts at the top of the room. And as a kind of quirk to GameMaker, but under the hood it does make a little bit of sense, the y-axis starts at 0, right? So 0 is at the top, and as we go down, y increases. So anything that has a low y should be drawing before things with a higher y. So what we basically have to do is stop the objects from drawing themselves in the wrong order. So basically disable their default draw events, and then we are going to draw them manually in the order that we want. And the way that we do that is just by making a list of all the instances that are going to be involved in this, collecting their y position, and then sorting them by their y position and drawing them in that order, in the correct order. And that's all there is to it conceptually. Okay, so to begin with, I'm not going to explain the very basics of setting up a project. I already have a player character that I can move around and just a few test items. That's all I really have in my project. That's all you need. And the first thing I kind of just want to explain is that, remember how I said it's the draw order that is kind of determining what instances draw first? By default, what controls that draw order is actually the instance creation order. So right here in the room, you can actually bring it up. And that can depend on where you place the instances in your layers at different depths. So you can see, for example, that my player is being created after the knight and scout, so it's actually going to be always drawing on top of them if I run my game at the moment. But that's not what we want. So what I'm actually going to do is I want a way to draw all of the instances in the order that I want and have them not draw themselves. So I'm actually going to have to kind of disable their own draw events eventually, and we're going to basically do this instead of going through every single instance and having them perform certain code. I'm going to make a parent object for anything that I want to be part of my depth system. And I'll just call that par_depth object, right? And I'm going to add all the children that I want to be part of the system. So my player, the scout, the knight, and I had some trees as well. Right, so they're all my children. And what I want all of my children to do right now is say visible equals false. So this is going to mean that their draw events aren't going to run. They have now taken themselves out of the draw pipeline in GameMaker, so they're not going to be drawing themselves. And just to show you, if I run the game, of course, nothing at all is drawing themselves. So they're still performing their step events, right? So the player, as you can see, is still moving around, but they're not drawing themselves. Okay, good. So that's fine. Now I'm going to have another kind of controller object, and I'm going to call this, well, you could call it depth sorter, or you could call it draw or master draw or whatever. I'm just going to call it depth sorter. And the way that I want to manage this is I kind of have to make a list of all of my depth objects, keep track of their Y positions in the room, and then kind of order that list relative to their Y positions. Right, so, and we're actually going to use a data structure for this because this is what data structures are great for. If you haven't used the data structure, that's fine. I'm going to be explaining everything you need to know as we go. But basically, so we're going to be using this one, a DS grid. And it literally will look like a grid. So it's kind of like as it says, a 2D array. It's got two axes, as you know, that's what a grid is. You can set how many columns and rows there are going to be. It calls it the X and Y axis. And like I said, our grid is going to have two columns and it's going to hold the instance IDs, right? So they're unique IDs. Every instance has its own unique ID, like its name in one column, and then it's going to store its Y position in the next one. And like I said, then we're going to sort the grid by the Y position so that we get the Ys that are the smallest up the top of the grid. And then we're basically going to go through that list one by one and draw all the instances. So that's kind of going to be sticking it onto our game canvas in the order that we want. So we're going to be using this function right here. So dsGridCreate. So let's type that in, and now we have to set a width and a height. So that's 2. And now what is our height going to be? Well, it's going to be however many instances there are in the room. Since that can change during the game, we are actually going to have to update this every step. Or actually, technically not every step, but every time there is a change in the number of instances in the room. So for now, we'll just set it as 1 and we'll resize it later. So this function is now going to create the grid and it's going to return the ID of that grid. So we have to save it in a variable. So let's save it in, I'm just going to call it ds depth grid. So the ds is just kind of reminding me that it's a data structure. You can call this whatever you want, of course. And now that we've created this grid, a special thing about data structures is that unlike other variables in the game, so just really quickly, you might not be aware of this, but when you use variables in your game or when you create anything basically, there is a little bit of memory in your computer that is kind of taken and dedicated to remembering a certain thing. So if I just create a variable called name equals Cosmo, there is a little bit of memory on my computer that is going to be sequestered when the game is running to remember that every time I put name now, I actually mean Cosmo. And once the game has finished running, once it's quit, or once the object is destroyed, then that gets cleared from your computer's memory, right? It doesn't just sit there forever. So then that memory can be reused for something else. But data structures don't do this. They're not part of that kind of waste disposal system. We have to actually dispose of it manually by ourselves. So we have to do that in the cleanup event, which is really easy. We just can write dsGrid destroy and then the ID of the grid, which is ds depth grid. There we go. So it's really simple. It's really easy to use a data structure like that. All right, so now that we are done, so we've created the data structure, now we actually have to put all of the information about the children objects into the grid, and then we have to sort the grid, and then we have to draw all the instances. And we're going to do that all in this draw event. Technically, you could do it in the step event. It doesn't actually matter. But to keep things simple, we can keep it all in this one event. So, like I said, the first thing that we have to do is make sure that the grid is the correct size. So I'm just going to make a comment. Resize grid. And now I'm about to be using the name ds depth grid a lot during this event. So I'm going to just create a little temporary variable to make it easier for myself to type over and over again. So just dgrid, or you can just call it grid, or even just like G if you want. All right, and so now when we dsgrid resize, so we can change the width and height of a certain grid, which is our dgrid, we know that the width is always going to be 2, so we can put that in. But now the height. So we need to set that to the instance number, right? So the number of children depth objects that there are in the room. And to do that, we can just get the instance number of parent depth object, because that is going to include all of the children that we put in that object. So there we go. Now we have the grid that is the correct size. Now we have to actually add the information to the grid. And really quickly, actually, before I move on, if you haven't really used these temporary variables before, since we've kind of been discussing data structures and different types of variables in memory, these are also kind of different to instance variables, which are these blue ones right here, because these blue ones, they will kind of be remembered for as long as this object exists in the game. And it will be, the memory for this will be destroyed once the object is destroyed. Temporary variables are a little bit different. They are actually destroyed as soon as this script is done running. And they also tend to be a little bit faster to access. And as well as that, they also have a different scope. So I can use this instance variable anywhere in the instance. So if I came to the step event and I said ds depth grid, right, it's going to refer to the depth grid. Or if I use the x and y variable, there are also instance variables that are unique to every instance and usable in any event. But if I typed dgrid over here, it doesn't have access to the local variable that we created in the draw event, because like I said, that gets destroyed when the script is done. All right, anyway, let's keep going. So let's add the instance information to the grid. And to do this, we are going to take advantage of a with statement. And a with statement is basically a way of getting access to a different instance, so something other than what is currently running this script, which is the depth sorter. So we can, instead of using the dot operator, for example, if we wanted to get access to obj balls y variable, which, like I said before, it's an instance variable, so we don't have access to it technically. If we just wrote y, it would not get obj balls y variable, it would get our own one. So by putting the dot operator, that kind of accesses the ball. And another way to do this is to say with the ball and then run whatever code I tell it to. So that is kind of jumping from whatever we are in to a different instance, and then it is going to run whatever code we put in here. And for example, if I put parent depth object, that will make all instances of parent depth object run the code, which is including its children. So I'm going to take advantage of that to add everyone to the grid. So now, the way that we access a grid is like this. So there is actually a function for adding stuff to the grid. So dsgrid add, and then it's dgrid the x position, which is the x-axis. So let's just put 0. So remember, the x-axis is the one going across. If we have a width of 2, then that means the very first column. And now for y, to get the coordinate of that cell, let's just say we put 0, and then whatever value we want to put in. So let's say that we wrote that. So like I said before, I want to fill the first column with the instance IDs and the second column with the y positions of the instances. So this would add the first instance to the correct position. And another way of writing that in here would be this. So it's just a little bit quicker than writing out that entire function, right? And this little hash thing is called an accessor. It's just a way of getting access to the grid. Different data structures have different ones. Like a map has a question mark, but the one for grids is that little hash. Now though, I don't want to actually just put a number for the y coordinate, because every instance that runs this then will be putting their ID in that very first row, which is not what we want. So we want actually to control this programmatically with a variable that we can increment every time this runs, because this is kind of like a loop. They don't all run this simultaneously. It's going to loop through every parent object one by one and have them run this code. So they can actually all affect a variable. So we can start at 0, kind of like we might in a loop. And then we can use this YY variable and then tell every single one of them to increase this, right? So we can say YY++, which is the same as putting YY plus equals 1, right? And now every single object is going to be adding to the Y variable. So the next one that comes along, YY would now equal 1, and it will put itself into the next position. The other important thing I want to point out is that this would not work if this was not a local variable. So if YY was declared out here within the scope of just the depth sorter, when we go with a different object, it's not going to have access to it anymore. And in fact, if I run the game, and you can test this yourself, it's going to declare an error. And actually, let's just take this opportunity to actually add it to the game. So I'm just going to add the depth sorter in, doesn't matter where. And if we just test that, right? So we're getting an error because YY has not been set in obj green tree, which is one of the children of my parent depth object. And that's because this is an instance variable. But if we put this right here, this is now a local variable, and the scope of that variable is this script. Anything in this script will have access to this variable. It doesn't matter if we go into a with statement. Anything in this script has access to this variable. So it's kind of a sneakier way of passing variables between objects. And that also goes for if you declare something inside here. Once we pop back out, we would then be able to access it still. All right, so anyway, we have added the ID of the objects, and as that runs through, that's actually going to fill in all of the object's IDs. And now let's add their Y positions to the second column. And I didn't point this out before, but just like arrays, data structures start their indexing at 0 instead of 1. A lot of things in programming are like that, you might have noticed. But that is an important point to remember. So in the second column, let's put the Y, the objects. Okay, so that is going to loop through every single object and add them to the grid. And in fact, at this point, because I encourage you to test as much as you possibly can, if we hit F6, we're going to run the game in debug mode, and nothing is still going to come up, but we can actually check if our data structure is getting filled correctly. So we just have to find, I had quite a few instances, so it's a little bit trickier. It's right down the bottom, the depth sorter. You can see this has appeared now. So you can see the index, interestingly, of data structures is actually just an integer. It's not an ID or anything. But if we view this as a DS grid, and enlarge this, you can see that's our grid. It has a width of 2 and a height of 62. That's the number of instances that I've got in my room. And you can look through the individual columns, and you can see there are all my instance IDs. That's what an instance ID looks like. And their Y positions are here. So it's good. Hopefully you see something similar like that. That is a quick way to check the contents of variables in your instances using the debugger. I find that especially helpful for testing data structures. You might realize at that point that the grid wasn't in any particular order for the Y positions. We had just kind of gone through all the objects in the room, added all of them to the grid, but they weren't in the right order. So now we'll sort each row of the grid so that the instance with the lowest Y position, so stuff in column 1 or column 2, but with the index of 1, of course, so that they end up at the top. And we can do this really easily. There is a handy function, which is kind of why I chose grids in the first place to use instead of arrays or something, is that they have functions for sorting. So we can say dgrid, and now it's asking what column do you want to sort by. I want to sort by column 1, and then it's asking, do you want to sort in ascending order? Yes, we do. True. So again, if you run that in debug mode one more time and have a look at your grid, it should now have the rows in the order that we want. Now all that's left to do is to sort through that grid and draw all the instances. So now we are going to do a very similar thing to what we did up here, but we are going to use an actual repeat loop this time. So I'm going to reuse that YY variable that I had before. I'm going to set it back to 0. I'm going to use a repeat loop. And now the number of times that I want to repeat is going to be just the number of instances that we have, right? I just want to pull out the instance ID, go with that object and tell it to draw itself, basically. So we just kind of have to pull out the ID, get access to that instance, just like we did with the with statement, and draw it. And of course, we do have to use a repeat statement. We can't just use the with statement again, because that's not going to go through the instances in the order that we want. We want to kind of determine the order that we're going to be looping through the instances this time. So we're still going to repeat by instance number. We are still going to be incrementing YY each time, because as we get access to the grid, we will be sorting through in an ascending order. So the first thing we do is just pull out the ID, and we can just save that in a variable. So I can go var inst equals, and then grab it from our grid. So remember the hash and the square brackets. So remember the instances were in column 1, which has an index of 0, and the row will be whatever YY is, right? And technically we don't have to be declaring inst over and over again in every single instance. We can actually do this outside right here, var inst. And we don't even have to set it to a value right here. We can actually just use it inside, right? So we've just kind of made it available here. So now that we have the instance ID, we just have to get the instance to draw itself. So we just go with the instance. And now previously, I had told you guys to basically just do draw self. And indeed, that is kind of the default draw event for instances. And if we run the game, everything is actually going to work at this point. And if you have a little walk around, you can see that the depth is working. But if you remember at the start, I actually had something different in my player's draw event. So if I come to it, I'll just show you. So basically, I had two things that it was drawing. It was drawing not only itself, which is kind of, this is equivalent to just draw self. I don't know why I didn't just put that. And this also draws a shadow of the instance. But that is not currently what it's doing. It's not drawing the shadow, it's only drawing itself. And that's because the draw object isn't telling it to run its draw event, it's just telling it to run this code. And we could have said anything. We could have said draw a circle. But perhaps you actually want it to run its own draw event. So we can go event perform ev draw. That's the type of draw event. And actually, I'll just quickly open this up just to clarify what that function does. So we can actually tell it to do any event. And just as a note, as you can see here, this event can't be forced outside of a draw event. So if I was in the step event currently of the depth sorter and I tried to draw something, it's not going to work. So this has to be called from within the draw event. So now we can access ev draw, begin, draw end, and everything. So if you have stuff in your draw begin or draw ends of your instances, you might want to add that to this system and insert the fact that you want them or want specific objects to draw their events in here. But to just access the normal draw event, that's what we would do. So now if I run this, you can see that my player object is working correctly. So it is currently performing its draw event. And I wanted to show you this. As you can see, everything else has disappeared. Just because I know a few people have trouble with this when I tell them this fix. But if you don't actually have anything in the draw event of your other objects, so like this one doesn't have a draw event, you're basically telling it to run its draw event, which currently has no code in it. So of course, nothing happens. So what we might want to do is put a draw event in your parent depth object, and we can just say draw self. So now if the object doesn't have an event, it will inherit that from its parent. So you can see it's coming up now. And now everything should be drawing themselves. There we go. So that is now working. So that is everything. That is how to set up a little depth system in your game. And in the next video, just because it has been requested a few times, I also want to go through adding a jump to the system. And it's quite a quick fix. It's basically just adding what's called a Z-axis to the game. So if you're interested in that, then go ahead and check out the next video. In the meantime, I hope you guys are all well, and I will see you next time.